Okay, so we are going to talk about total internal reflection, which is another phenomenon of refraction. So let's understand the concept or what it is all about. Now, imagine that we have a glass block. This is a glass block, and then we have a light ray that is moving from glass into air. So this is air. We have air on this side. This is glass. This is glass. Okay, so I have a ray of light that is moving out from glass and going into air. Of course, this is how the angle of refraction will be. This is angle of refraction, and this is the angle of incidence. Now, something interesting happens. So mind you, I said that the direction of the light is from glass to what? Air. Or you can say from denser medium to less dense what? Medium. Something interesting happens here. If I keep increasing the angle of incidence, this angle of refraction will also be increasing. So as this guy is going up like this guy is going down. So this angle is also increasing as this one is increasing. Okay? Now, what is that interesting thing that will happen? Now, if I keep increasing the angle of incidence, it will get to a point where this line that was like this before will now be on this side. Let me draw another diagram so that you see what I'm talking about. So, if I keep increasing that angle of incidence, if I keep increasing this angle of incidence, then I will get to a point where if I have a certain angle of incidence, the angle of refraction here will now be 90. So R is equal to 90 here. How did it become 90? I was increasing this guy gradually. As I was increasing, it came to a point where the angle of refraction is equal to 90. Now, if that happens, the angle of incidence that gave us that angle of refraction of 90 is called critical angle. It's called what? Critical angle. So I becomes equal to C at this point, and C is critical angle. Okay? Critical angle. So that angle of incidence in the denser medium that gives us the angle of refraction of 90 degrees in the less dense medium is known as the critical angle, just in case they ask you that in your WAEC exam, so you know how to define that. And then mathematically you should know that sine C is equal to 1 over n. We are going to solve some examples with this formula. So sine C is equal to 1 over n. Remember what n is again? N is your what? Refractive index. Now C is your critical angle. So the critical angle, the sine of the critical angle is equal to 1 over n, 1 over refractive index. Now, but we are not done here. So remember, how did we get to this diagram? We started from here. If we increase the angle of incidence, it will get to a point where the angle of refraction becomes 90. That is how we got to this diagram. Then, what if we increase it further? What if we now say, okay, let's increase it further until we pass the critical angle? So from this diagram now, we get another diagram. Okay? So let's see. We now increase our angle of incidence such that our angle of incidence is now greater than C. So if our angle of incidence is now greater than the critical angle, you see that the line will no longer be here. The line will now do as if it is coming inside like this, because I have increased it further. So look at my angle of refraction now. It has now come back into the medium. So looking at this line now, you will observe that this is no longer refraction. This is now reflection, because this is what we mean. In reflection, the ray strikes the mirror or whatever and bounces back into that medium that it is coming from. So that is exactly what happens here. So you see that if the angle of incidence is bigger than the critical angle, that instead of the ray to move out of the medium, it bounces back into that medium, and that is why it is called total internal reflection. That is what we know as total internal reflection. So in exam, they are going to ask you this important question. They will ask you, what are the conditions for total internal reflection to occur? You will tell them that the first condition for total internal reflection to occur is that light must travel from a denser medium to less dense medium, less dense to a less dense medium. That is the first condition. It must travel from a denser medium to a less dense medium. First condition. And then second condition is that critical angle must be exceeded. Critical angle must be exceeded. Must be exceeded. Critical angle must be exceeded. So what does that mean? The first one is saying that the light must travel from a denser medium to a less dense medium. I have seen a JAM question where they said, in which of the following can total internal reflection occur? And they gave several instances. In option A, they will say something like air to glass. Option B, they will say something like water to glass. Option C, they will say something like maybe glass to air. Option D, you will have maybe something else. You see that the answer to that question is glass to air, because going from glass to air is from denser to less dense. Is from denser to what? To less dense. What if I see something like going from glass to water? Will it happen? Yes, it will happen, because glass is optically denser than what? Than water. So total internal reflection will happen when light is going from glass to water. Will it happen when it is going from water to glass? No, because water is less dense than glass. That is what we mean by that. Okay, so that is the concept of total internal reflection. And if you observe, you see that because of this phenomenon of total internal reflection, we can use it to explain the formation of what we call mirage. Okay, what we call mirage. What we call mirage. So when we have mirage is an optical illusion. Okay, is an optical illusion. When I say optical illusion, what do I mean? Something that maybe your eye is telling you that something is there, but it's not there. Okay, more like seeing a ghost. Yeah, we know that ghosts don't exist in physics, but it is similar to that. So an optical illusion is something, maybe your eye is telling you that something is there, but it is not there. Now imagine you are inside your vehicle traveling on a tarred road in a hot afternoon. You see that when you look ahead, it's as if there is a pool of water ahead of the road. If you observe, there is a pool of water ahead of you, and you see that as you are getting close to that pool of water, it will be pulling away from you. So that thing is what we call mirage, and it is formed due to total internal reflection. So take note of that. Very important. Okay, so we are going to see an example on total internal reflection.